Hello everyone. Today I am presenting on the topic vertex cover problem, minimizing and monitoring points. This is very important concept to in a graph theory which is used in network design, CCTV planning and social media connections and many real world systems. My group presenting this. Before I start, my main goal to in this explain the ideal in a simple and visual way so that everyone can understand how vertex cover helps reduce cost and improve efficiency. Now let us discuss about graph theory. A graph is a picture made of points and lines. Here points are called vertex and lines are called edges. A vertex represents an object in the network, like a city, a person, a computer, or even a server. An edge shows that connection between 2 points, like road, a friendship, or a cable, etc. One important advantage of graph is that they specific very complex networks. For example, a huge city with thousands of roads can be represented easily using just vertices and edges. Let us take a beautiful example for graph. Let us take 4 points A, B, C, and D, and the connecting lines AB, AC, and BC, BD, and CD. These are here. The vertices are A, B, C, D. Let us think this A, B, C, D as cities, and this connection between them are roads. A perfect example for this is vertices means cities, edges means connection between the cities, that means roads or any other. This example can represent a small area in a city, a small computer network, or even a mini social network. This type of representing helps us understand how objects are connected between them. So this is clear about graph. We are discussing about vertex now. Vertex theory focus on the importance of specific points in a graph. Vertex means a point in a graph. Some vertices are more important because by selecting them we can cover or monitor the entire network easily. In real life placing resources, everyone is costly. Everywhere is costly. So instead of using many monitoring points, vertex theory helps us to pick only a few key positions that can cover all connections. Now let us take a example to understand this very clearly. In this, let us imagine this is a city map where ABCD is cities. These are the junction between them. If we want to cover all the roads with CCTV, we don't need cameras at every junction. If we place a camera at A and D, every road is covered. Here, A and D is covering. If we place CC camera at A and D, we can cover all the roads or all the junctions we have covered. So it will reduce cost. This shows the power of vertex cover, using fewer resources while getting full coverage. Let us discuss about difference between graph and vertex. A graph shows the whole network or all points and connections, where vertex shows only one single point in the structure. Represents Graph represents the complete network, where vertex represents one element of the network. Graph made up of many vertices and edges. Vertex, it is a part of the graph. The example for graph we have discussed earlier, city map with all roads and junctions, where vertex we have discussed one junction in that map. Graph used to understand or study overall connections. Vertex used to focus on specific locations or nodes. We using vertex to reduce cost. As we discuss CC cameras for placing all, we can place a D or A and D in this present slide. In this slide, A and D, it will reduce cost compared to all. Let us discuss a real life examples for graph and vertex. Graphs and vertex are used everywhere. On the left, we see a graph representing a full network. Imagine it shows 4 points A, B, C, D connected by lines. It represents the whole network, showing all connections like a city map with roads and junctions. Many points, vertices connected by lines. These vertices are cities, and the connected lines between them are roads, as we discuss vertex and edges. Example for this is city map with roads and junctions. We can easily understand this example. That's why I am taken this. Here, let us come for vertex. The right side picture we saw means it will shows a blue color person representing the social network. The image shows one blue person connected to other gray persons. It represents one single point in the graph, like one person in social network. One node vertex connected to others. As we use Instagram in this, if I am the Instagram person, the suggestions and the post recommendations coming from another is called vertex. Example, social network with one user connected to friends like Instagram. Let me give two real life applications. Google Maps use graph to find shortest routes. Instagram user vertex to suggest friends. To conclude, the vertex cover problem helps us identify the minimum number of monitoring points required to cover all the connections. It is powerful because it reduces cost, improves efficiency, and it is used to many technologies. This is why graph theory is one of the most important part of computer science. Finally, I'm concluding this is graph and vertex are more important, and the uh, remaining part will be covered by our friends as follows. Thank you for giving this opportunity.
Hello guys, good evening. My name is Tesh. Today I'm going to tell about the topics of vertex cover, edge cover, and their differences and their examples, and the real life uses for the vertex cover. In this vertex cover, the vertex cover is used um, to cover all the vertices or pointers such that every edge or line in the graph touches at least one of these selected vertices. And why do we use them? To make sure all edges are covered using the minimum number of vertices. For example, in the diagram, we have taken three vertices A, B, C. This line is AB, and this line is this edge is AC, and this edge is BC. At here, this edge touches the vertices of A and B. In the this edge touches as the it was covered by the this edge was covered by the A, and this edge was covered by the B. So this we can use A and B as the vertex cover so that all the edges are covered. So these two vertices can be cover all the edges in the diagram. So like that, we can take another example. Uh, In this example, they have given the edges of each given graph, that is 1 comma 6, 1 comma 2, 1 comma 4, 2 comma 3, and so on. First 1 comma 6, we have drawn the edge. One is a vertex and 6 is a vertex, and we have drawn the edge same as this. We have drawn to the every vertices to the vertices and edge. This is the whole diagram if we draw by the given graph. In this, first we have to take a certain vertex. Let us take the one as a vertex. From one, we have the edges to 1 to 2, 1 to 4, 1 to 6, and 6 to 7. And we can take from this any one edge, so that we can be so that every vertices can be covered. So I have taken the 1 and 6, so that 1 and 6 vertices are covered by this edge. After that, I have taken the 2, so that 2 is connected with 4, 3, and 3 is connected with 5 and 8. So that uh, if I take 2 and 3 vertices are covered by this edge. That is called 2 and 3. And same as this, we have taken the 4. From 4, we have connected the 4 and 7 vertices are connected by this edge. So that 7 is 7 is connected to 8 and 4 is connected to 1, so that we have already taken 1 and 6, 2 and 3 as vertices. So from 4 and 7 are connected to this edge, so that 4 and 7 are also connected. After that, we have taken 8 and 5, so that we have got all vertices are connected by these 4 edges. See, here 1 and 6 are connected to the edge, so that we got 1 and 6 number, and 4 and 7, these two are connected by this edge, so that these are covered. And then 2 and 3, these vertices are covered by this edge, so that these two numbers are covered. And here 8 and 5 are connected with this edge, so that these two are covered. So like that, every vertices are covered by the edges. So this is called the vertex cover. And let's go to the edge cover. Edge cover is nothing but which is opposite idea of vertex. An edge cover is set of edges such that every vertex is connected to at least one of the selected edge. Instead of covering edges, we are now covering vertex. Example, to cover vertex A, B, C, D, we can choose edge AD. Here we can choose AD covers A and D, and edge AB that covers A and B. We can choose AC that covers A and C, so that we don't need this edge. These three edges cover all the vertices. At the above vertex cover, it covers all the vertices by the edges. In this, it covers all the vertices by edges. That's the main point. And the differences between the vertex cover and edge cover is the vertex cover chooses vertices, and edge cover chooses the edges. And vertex cover covers all the edges, and edge cover covers all vertices. In every vertex cover, every edge must touch a chosen vertex, and same as the edge cover should be every vertex must touch a chosen edge. And vertex cover subset of vertices. Edge cover is a subset of edges. Example, vertex cover has been in A comma B in this previous. In this A comma B is the total vertex cover, and here we have the edge cover is A comma B and A comma C, so that all the vertices have been covered. Um, and there are real life applications mentioned, so that network security, social network, transportation network, sensor network. We can talk about this. Network securities. In this network securities, in computer networks, we want to protect every connections, so that we use vertex cover. We can place the minimum number of firewalls or monitoring systems so that all communications links are protected. This helps reduces cost while keeping the entire firewall network safe. And the second point is social network. In social network, social media, some people acts as key influence. Vertex cover helps select a few important people, vertices. These people are called as vertices who can spread information to the entire network. This is used in marketing, advertising, and rumor tracking. And the third point is transportation networks. In a traffic network, we want to monitor all roads using vertex cover. We place minimum cameras at intersection so that all roads connection connected to those points are covered. This reduces camera's cost and still gives full monitoring. And the fourth point is sensor networking. This is very complicated. That the first above three are very important. The sensor network is also nothing but the to detect communication links or movements. We try to use minimum sensors so that vertex cover finds the least number of sensor position needed so that every connection is detected. This makes the system efficient and cheaper. Uh, and you can see this that in the diagram. In this computer network firewall, um, only a few firewalls are placed at important computers so that all traffic is checked from one computer to another computer. And in the social network with key influences, these are the vertices and this is the edges, so that everyone could transfer the information from one to another. A few selected people spread messages to everyone. And here you can see the road network with camera points. This is the junction, and you can place the cameras as a vertex cover. And the cameras placed at key junction cover all roads. It covers all the roads and keep the people safe. Uh, Thank you.
Hi, today I'm going to speak about a vertex cover problem. A vertex cover is a group of selected nodes in a graph. A graph has vertices, points, and edges connecting them. A set of vertices is called a vertex cover. Every edge in the graph touches at least one vertex from this selected set. In other words, for every connection edge or edge, at least one of the endpoint must be chosen. And minimum vertex cover is the smallest possible set of vertices that still covers all edges. Finding this smallest set is difficult because the problem is NP complete, meaning there is no fast guaranteed method to get a perfect answer for big graphs. We often use tricks, shortcuts, or approximation. This concept is very important in fields like networks security, biology, social networks, and computer chips design. Types of vertex cover. Minimum vertex cover. This is the best or smallest vertex cover possible. You pick the fewest numbers of vertices while still covering all edges. The second one, minimal vertex cover. This means you cannot remove any vertex from the set without leaving some edges uncovered, but it might not be the smallest cover. Example, small but not minimum. Approximate or approximate vertex cover, because finding the perfect answer is slow. We use greedy methods or approximation algorithms. This gives good but not always perfect solutions. For example, sometimes we pick both endpoints of a uncovered edge, giving a solution at most twice the optimal size. The fourth one, vertex cover is in special graphs. In some graphs like trees or planar graphs, we can find the minimum vertex cover faster using special algorithms. Why minimizing redundancy is important? Redundancy means adding extra vertices that are not needed. Why is it bad? It increases cost. It reduces efficiency. It wastes time and memory in applications. It makes solutions heavier and sometimes slower for other algorithms that depend on the vertex cover. If we minimize redundancy, the solution becomes clear. We use fewer resources. This result is closer to the minimum vertex cover, which is what we always want. The system becomes more efficient. Why exactly is the vertex cover problem? There are two main versions. First decision version, yes or no question. You are given a graph and a number k. Is there a vertex cover with k or fewer vertices? This version is used in complexity theory and it is NP complete. The second one, optimization version, find the smallest possible number of vertices that covers all edges. This is the real goal in most practical cases. Um, the vertex cover problem, we are given a graph, a set of points and lines. We must choose some vertices so that every edge connects at least one chosen vertex. The goal is to find the smallest number of vertices that cover all edges. Example, if a graph has edges A to B, B to C, and C to D, they they're picking B to C covers all edges that's a vertex cover. The importance of minimizing redundancy, we keep the cover small, fewer vertices, less repetition, and less cost. Makes algorithm faster and simpler. Helps in real world uses like network monitoring, fewer sensors needed. Security cameras cover all areas with fewer cameras. Social networks track connections using fewer people. In short, minimizing redundancy means using just vertex cover, network monitoring, placing monitors at some nodes so that all communications links are monitored. Social networks, selecting key people, vertices to cover all friendships, edges. Bioinformatics, modeling protein interreactions, choosing proteins that interact with all others. Compiler design, register interference graph. Vertex cover helps detect which variables can share registers. Facility locations, selecting minimum warehouses so that every distribution route is served. Some approaches to solve vertex cover. Uh, exact algorithms, brute force, try all subsets, backtracking, reduces search time, integer linear programming, formlets as ILP and user solvers, approximation algorithms. There are two. A simple algorithm gives a simple solution at most twice the optimal size. First one, pick any edge, add both U and V cover, remove all edges incident on them, and repeat. The time complexity is um, special graph cases. Some graph cases allow polynomial time algorithm. The vertex cover example, graph edges 1 to 2, 2 to 3, 3 to 4. Possible vertex covers are 2 to 3. Minimum vertex cover is 2. The important properties, every graph has a vertex cover. Minimum vertex cover is unique only for some graphs. For a graph with m edges, if a vertex has very high degree, it is often included in optimal solutions. Uh, and the summary is vertex cover is equals to some set of vertices covering all edges. Minimum vertex cover is NP hard. Asian version NP complete related to independent sets and uh, approximable with factor 2 used in networks, social graphs, and compiler designs. Thank you.
My name is G. Abhiram. Now I'm going to explain about NP completeness explanation. What is NP complete? P represents polynomial time. P problems are problems that can be solved efficiently using an algorithm whose runtiming is polynomial. Definition: problem belongs to class P if it can be solved in time. O of n, like O of n, O of n square, O of n power 4, O of n cube, etc. Examples: sorting numbers, searching in an array, finding maximum or minimum, binary search, merging two lists, etc. The characteristics of P class are fast, reliable, practical, computation grows slowly. Example: sorting 1 lakh numbers using merge sort, solved in seconds. What is NP class? NP represents non-deterministic polynomial time. These problems are hard to solve but easy to verify. A problem belongs to NP if a solution can be verified in polynomial time. And even an important note, NP does not mean not polynomial, it means verifiable in polynomial time. Example: Sudoku, finding a solution difficult, checking a complete puzzle is a easy task. Another example: subset sum problem. Given numbers 3, 34, 4, 12, 5, 2. Target is 9. Finding a subset that gives 9 is harder, but if someone gives 4, 5, you can verify instantly. The relationship between P and NP is P belongs to NP, meaning if a problem can be solved fast, it can also be verified fast. NP complete is equal to no known efficient algorithm. If you solve one NP complete problem efficiently, you solve all NP problems efficiently. This would mean P is equal to NP. Real life analogy: you have many locks, one master lock. If you break the master lock, you can open all locks. Example of NP problems: traveling salesman problem, 0 by 1 knapsack, graph coloring, vertex cover, Hamilton path, SAT problem. We can prove a problem is NP by showing problems is in NP. Choose a known NP complete problem, reduce known problem to the new problem. If success, then it is called an NP completer. Why are NP complete problems important? Because these are important because optimization problems, we can do optimization problems, AI planning, scheduling, cryptography, circuit design, all involve NP complete problems. Now let's talk about why algorithms and pseudocode. Now first let's learn what is an algorithm. An algorithm is a set of clear logic steps used to solve a problem. Just like a recipe tells you how to cook the food step by step, an algorithm tells a computer how to solve a problem step by step problem solving. Algorithms give a proper order of steps to reach the solution. With an algorithm, solutions become confusing, mistakes happen easily, results may wrong. How to write an algorithm: work is organized, every step is clear, result is correct. Example: to find the biggest number in a list, we need to start with the first number, then compare it with others and keep the large value. And we need algorithms for accuracy and correctness. Algorithm ensure correct output, no missing steps, and logical processing. When an algorithm is well designed, it always gives correct answers for valid inputs. Error chances are reduced. And algorithms can be useful for efficiency, time and space analysis. Algorithm helps us decide how fast a program will run, how much memory it will use, and its time complexity is measured how execution time grows when input size increases. Complex complexity measures how much memory is required. Example, sorting 10 numbers is faster. Sorting 1 million numbers is slower. Algorithms helps us pick the fastest method. And algorithms can be reusable. Well-written algorithms can be used again, modified for new problems, shared across systems. Example, search algorithms are used in Google databases, mobile apps, and etc. And algorithms are used in easy debugging and maintenance. Using a clear algorithm makes errors easier to find, programs easier to improve, updates simpler. And now let's talk about why do we use pseudocode. Now let's learn what is a pseudocode. A pseudocode a pseudocode is an informal way of writing an algorithm using plain English and simple logic. It is not a programming language, not strict about syntax, easy to read. Example, start, input numbers, add them, print result, end. And the pseudocode is used to focus on logic, not syntax. Pseudocode avoids semicolons, brackets, programming rules, so you can focus on problem logic thinking clearly, step order. And it is easy to understand for everyone. Pseudocode is language independent, can be understood by programmers, teachers, students, and managers in the company. Even if someone doesn't know C, Java, or Python, they will understand the pseudocode. And it helps in error checking before coding. By writing pseudocode, errors are detected early, logic is corrected easily, coding becomes faster later, and it improves communication. Teams use pseudocode to explain ideas, discuss logic, avoid misunderstandings. Thank you.